Archimedes' principle tells us that
an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces.
if we multiply the volume we're talking about by the density of water, we get our buoyant force.
So, what determines whether an object's buoyant force is able to keep it afloat?
In a word, density. If it's more dense than water, then its weight will exceed the buoyant force acting on it, and it will sink. Though the hull of a ship is typically made of steel, which is obviously considerably more dense than water, a vast amount of its internal space is empty, except for air. Thus, the ship is, on average, less dense than water.
We are familiar with gravity as the reason objects fall. But what is gravity? Sir Isaac Newton described gravity as an attractive force between all objects with mass. He described gravity as a mysterious action at a distance. Einstein described gravity as the bending of space and time. The reality is that gravity keeps us from falling off the Earth, and it's what keeps the Earth in orbit around the Sun, and it's what caused the Sun, planets, and moons to form. Every object with mass attracts every other object with mass. That means your dog, the moon, and a huge star are all attracted to you and you to them. In simple terms, this means the law of gravitation states all objects in the universe attract each other through gravitational force, and the law depends on mass and distance. As the distance between the two objects gets larger, the force of the gravity gets much smaller. The reality of Einstein's view and Newton's view is that gravity depends on mass and distance.
Would you believe air is a fluid? Yes, it is, and I will visually show and explain why air is considered a fluid along with liquids. This video was made to help identify the properties of fluids because many of my present and future science experiment videos that applies to real-life situations requires the knowledge of fluids. What is a fluid? Liquids and gases are fluids. A fluid takes the shape of its container and flows. Water, see, the water is a liquid fluid. It takes the shape of its container and it flows. Anything in there? Yes, there's something in there. It's called air. Air flows. See the paper? And it takes the shape of its container. Since you can't see it here, I'm going to show with this balloon. See, I just put the gas air into the balloon. It takes the shape of the balloon, or you can see the container, and it floats.
I have a floating ball, but did you know that there is no buoyancy force on this ball if you don't have gravity? If you're in space, there's no buoyancy force, and it's because of the following. So I have an object underwater that's floating. Then, of course, the upwards pushing buoyancy force is equal to the downwards weight. But we can also model the buoyancy force as a result of the water pressure. So as you get deeper in the water, the pressure increases rho GH, where that's the density of the water, and that's the gravitational field. So because of the gravitational field, the pressure is larger down there. That means that the upwards pushing force from that higher pressure is greater than the downwards pushing force from there, where the pressure is lower. So if you just take that water and you put it in space, and there's no gravitational force except for its collapse, and things don't float. They only float because of gravity.
I don't think so.